Welcome to section 6.3, separable differential equations. What is a separable equation? Well, that's an equation where all x terms can be collected on the same side with the differential x, and all our y terms are matched up on the side with the differential y. That's said to be separable then when we get it into that state where x's are on one side, y's are on the other. A separable equation is one that can be written in the form dy dx is equal to f of x times gy, and then we can separate it and pick up where we have all y terms on one side, and then you'll notice f of x times differential x on the other side. Mainly, that's how we're going to approach these type of problems, is to take a differential equation dy dx, where we have maybe a couple terms or functions multiplied, and turn it into a separable equation. And then we can go ahead and integrate. So there's step number one. Let's separate variables. So separate variables, and we'll do that through algebraic methods. So I will want to multiply, it appears, by y on each side. So I have dy dx is equal to 2x over y. And then we're going to come through and multiply by y on each side. And that will lead us to y dy dx is equal to 2x. And finally, I want to get rid of the dx, so let's multiply by dx on both sides, differential x. And that brings us to an equation that has a separation of variables. So I have y dy is equal to 2x dx. A good place to begin integrating. So now let's do an integration on each side. And the integral of y will be y squared divided by 2 equals, I could put plus c, but I would just end up adding that c or subtracting that c to the other side. The integral of 2x becomes x squared plus c. That would have been what? A 2x raised to the second divided by 2, and our 2's will cancel. So we're at this point. Now, our objective is to take and get rid of the 2 here, so we'll multiply both sides by 2, and that'll give me 2x squared plus 2 times c, or I could call it a new c. So I'm just going to keep running with a constant c. And finally, if I want to get very explicit, I could say y is equal to either the positive or the negative case of 2x squared plus c. If I had an initial point given to me, I would be able to determine whether I'm talking about the positive square root equation or the negative square root equation. So, separable differential equations, really not too hard to handle. A nice straightforward one. Number 2, maybe a slight bit more difficult. Let's take this and multiply both sides by a dx to move it to the right side, and then I think I want to bring that y over. If you want to do it in 2 separate steps, feel free to. Let's do that. We'll multiply by differential x on this side, giving me dy equals 1 plus x over x times y times dx. And when I analyze, take a look at the left side, I have nothing but y values, perfect. But when I look over here on the right side, I have an issue with my y being there, so I still want to get rid of y. So let's multiply both sides by a y and get the y over the y to cancel. And now I have y dy is equal to 1 plus x over x dx. And introduce an integration. Let's integrate both sides. And we know the integral on this side will be y squared over 2 is equal to, oh, what are we going to do with that right side? Well, one technique we could do, we could shift this into the integral of 1 over x plus x over x dx. And that would be, I'm going to just do a simple replacement here, 1 over x plus 1 multiplied by differential x. All right, I think I can integrate that. Now I recognize the first pattern as a natural log absolute value of x plus the integral of 1 is just x, and then it's an indefinite integral, so let's pick up our c. Multiply both sides by a 2, and we will have y squared equals 2 times the natural log absolute value of x plus 2x plus 2 times c, but that could be restated as a new constant. And that is almost done, right? This 2 out front of the natural log, why don't we restate that and bring that back up as a power to x, and then I can remove my absolute values since squaring x will result always in a positive value, and I would have that. And then I can say y is equal to plus or minus the square root of natural log x squared plus 2x plus c. And that finishes that problem. The third problem. Well, I can multiply by dx to bring it to the right side, and I could divide by y to bring it to the left side. So the result would look like 1 over y dy is equal to 4, which let's just leave it there on the right side dx. And we want to get rid of our differentials, so let's integrate, solve these equations, or this equation. On the left side, I pick that up as natural log of y is equal to 4x plus c. And natural log of y is not probably the state I want to leave that in. So here's what we're going to do. Let's get rid of this natural log by introducing e as our base on both sides. And e to the natural log of y will be just absolute value y. And since I have e to the power of something on the right, I know that this is going to be an always positive result because e raised to any power will be positive, and so I can remove my absolute value signs at this stage. Okay, this is a much prettier picture, but we can do one step better, and that is to think about the right side here, e to the 4x plus c. Well, if I had 2 to the x and 2 to the third, I would bring this together and say I have 2 to the x plus 3. Okay, now make an analogy over to our problem. I'm starting with what I finished. And so I have e to something that was added. That would be similar to stating this then, e to the 4x, e to the c. So I can break them back down into their components here. And finally, I know that e raised to the c, this is really going to be just a new constant. E to the c, that's going to describe a new constant to us. So it'll have multiplication, so I'm just going to throw c in the front. C times e to the 4x. Take a look at that and just kind of study that for a bit. Number 4. Okay, this was starting to look a little more intense, isn't it? We want to separate our variables. Remember, that's kind of the first step, is to separate variables. And I can see that y minus 1 being multiplied on both sides and bringing it up. Oh, and over on the left side, we have different notation going on, right? But we know what the meaning of that is. Y prime could be restated as not dx, but dy dx. is equal to 3x squared plus 4x plus 2. And so let's make the dx come up over to this side. Oops, you know what? I lost my denominator. 2y minus 1. And then let's multiply. So multiply by dx on both sides. It's gone. We got dy equals. Let's multiply by the 2y minus 1. And leave that there. And that's going to equal 3x squared plus 4x plus 2, all multiplied by dx. Introduce your integration. And if I integrate this, I'm going to have 2 times y squared divided by 2 minus y plus a c, but I don't need to write that one. And then I'll have x cubed. Now I'll just write out 3x cubed divided by 3. The 3's are going to cancel. Plus 4x squared divided by 2. We're going to get some canceling. Plus 2x plus c. Next, I think I'm going to go ahead and distribute. So I'll have a y squared minus a 2y equals x cubed plus 2x squared plus 2x plus c. This would be, you know, an implicit form of an equation, but I bet we could even get it simplified a little bit more. And, ooh, that's a different problem. I'm sorry. Oh, we had the value. There's where I'm at. We had this value also given, if we look back up to the top, we had a value given of passing through the point 0, -1. So let's come and figure out our c value before I go any further, because I think I want to take this to an explicit, but let's find c before we move any further. Find c. And we know we pass through 0, 1. 0, -1. So like always, we're going to put in 0 where we see x and -1 where we see y. So I'm going to have -1 squared minus 2 times -1 equals 0 plus 0 plus 0 plus 0 plus c. And that means that c is equal to 1 plus 2. And therefore we have concluded that c must be 3. So now we come back and let's rewrite our equation including c. So we're at y squared minus 2y equals, I'm going to leave a little space on purpose, you'll see why in a moment, x cubed plus 2x squared plus 2x plus 3. Now, in order to solve for y, which I've got this quadratic going, I am going to complete the square on this. So we're going to take that middle term, divide it by 2, and add the square of that result. So -2, well, 2 divided by 2 is 1, squared is 1. So we completed the square. Since I added 1 on the left side, I'm going to balance it by adding 1 on the right side. All right, where does that take us? Well, we are going to have, let's scroll this up a bit. Long problem, isn't it? Y minus 1 quantity squared is equal to x cubed plus 2x squared plus 2x plus 4. Now, let's square root both sides, and we have y minus 1 is equal to plus or minus the square root of x cubed plus 2x squared plus 2x plus 4. Now, I guess the final step, we could add 1 to the other side, couldn't we? I have y equals plus or minus square root x cubed plus 2x squared plus 2x plus 4 1 outside the square root, and we want to figure out whether this is the plus or minus case. And in this one, we can actually figure it out. Okay, so we want to solve the plus or minus dilemma. And the way we do that is we look at our original ordered pair, which was when I plug in 0, I want to end up with -1. So what I can do is I can substitute these values in and check it out. So -1 is equal to plus or minus. Well, much of that's turning out to be 0 in there, except for the 4 will stick, and we'll have the +1. -1 is equal to plus or minus 2 plus 1. Well, now just thinking with arithmetic, we definitely need the 2 to be negative. And so I have just concluded that it is, as a final result, y equals negative square root x cubed plus 2x squared plus 2x plus 4 plus 1 outside the square root. And that is our solution to the differential equation. Love it? All right. Finally, fifth one. Final one. Find the particular solution that satisfies the initial condition. And once again, we see a y prime sitting in there. So maybe we want to, restate this as 2x dy dx equals natural log x squared. Oh, I'm sorry. I added the natural log x squared over just kind of automatically. Works for us, doesn't it? And now let's, oh boy, we can do quite a bit with this. I'm thinking of using my natural log property and bring that 2 down from the power of the x. And then let's go into division, divide both sides by 2x. And we will notice that we get 2 canceling and 2 canceling. That's sweet. Oh, I left off the x. X is canceling too. And I'm at dy dx equals natural log x over x. I have not quite separated my variables, which is, always our first step on these, separate variables. I'm trying to get x's on one side, y's on the other. So let's multiply by dx, and we've achieved it. dy equals, this one isn't quite as long as the last problem, dy equals natural log x over x dx. Introduce your integral symbol, because we are going to integrate both sides. The integral of dy will be y. And now, I hope you recognize this. You could do, oh, you love this. You could do a little u sub on this one if you are wondering. Take u, let it be natural log x. Then the derivative of this would be 1 over x dx. And you're excited because this is working out so sweet. Here is the x, 1 over x dx, that'll get replaced with du, and I'll have the integral of u du. And that means that I have y equals u squared divided by 2 plus c. Replace your u squared with your natural log, and we'll have, I'm going to throw the 1/2 out front. 1/2 natural log of x quantity squared plus c. I cannot move that 2 down because we're talking about the quantity of natural log x, not just x being squared. Okay, here's what I was looking for. I had to scroll up for it. We've got y of 1 equals 2, an initial condition. And anytime we have an initial condition, we can actually solve for c. So take this initial condition and use it. So the initial condition was when, I gotta relook at it, 1, 2. So we will put in 2 for y, 1/2 natural log of 1 quantity squared plus a c. 2 equals 1/2. The natural log of 1, we all know it's 0. And so this is going to be 0 squared, which is 0 plus c. Oh, it looks like c is coming out to be 2. And we are so close to the finish line. Rewrite using c. So put our c in place, and I'm kind of looking way up here. And we have y equals 1/2 natural log x quantity squared plus the 2 for c. And you got yourself a differential equation all solved. Beautiful. That is the notes for the day. You can rewatch it. I'll post it to Schoology as well. And this is the homework that should be sitting in your packet. So do those few problems, please, for tomorrow, and I will see you in class.